Establishing whether life ever existed on Mars is one of the outstanding scientific questions of our time. To address this important goal, the European Space Agency, ESA, is preparing, together with the Russian space agency Roscosmos, the ExoMars 2022 mission, whose rover will leave equipped with a real laboratory for biological analysis. ExoMars 2022, in fact, will deliver a rover named Rosalind Franklin and a Russian surface platform named Kazachok to the surface of Mars. A Proton rocket will be used to launch the mission, which will arrive at Mars after a 9-month journey. The ExoMars rover will travel across the Martian surface to search for signs of life. It will collect samples with a drill and analyze them with next-generation instruments. ExoMars will be the first mission to combine the capability to move across the surface and to study Mars to a depth of 2 meters. And perhaps it will be the mission of redemption for Europe, which so far has never managed to bring down one of its rovers or landers onto the Martian surface. Or at least, that's what we all hope, because the Rosalind Franklin rover, more than all others sent so far, is the one with the best chance of finding life on Mars, if any. ExoMars mission. If there is life on Mars, we will know for sure in 2023. It's been almost half a century since the European Space Agency was born in Paris. It was May 30th, 1975. 10 countries of the old continent met in the name of science to create an agency that could keep up with the two superpowers that then dominated the space sector, the Soviet Union and the United States. And in all these years, ESA has certainly succeeded in achieving the goal it had set itself, becoming a space exploration power and supporting a market, that of the new space economy, which in recent years has seen unprecedented growth. The first great successes of ESA began in 1986 with the probe Giotto, sent to meet Halley and to photograph for the first time ever the nucleus of a comet. Then many other missions, such as Hipparcos in 1989, to measure the real distance of tens of thousands of stars, and the Ulysses probe sent to the Sun in 1990. Not to mention the Huygens probe, sent to land on Titan in 2005, and which is still the spacecraft that has made a soft landing farthest from Earth. And all while the mother probe Cassini, the result of collaboration with NASA, explored the Saturn system, making us participants in extraordinary scientific discoveries. But there is much more. Spacecraft sent to Venus and Mercury, or space telescopes sent to search for data on the cosmic background radiation, like Planck in 2009, or like Herschel in the same year, who flew to the second Lagrangian point of the Earth to hunt for extrasolar planets. And in 2014, the exciting adventure given to us by the Rosetta probe, which you will all remember for the extraordinary photos taken of the comet Churyumov-Gerasimenko, and for the first landing on a cometary nucleus. But that's not enough. Around our planet there are dozens of satellites put into orbit by the old continent. Some of them are telescopes and probes that scan the cosmos. One of them is Hubble, realized in partnership with NASA. Others, instead, observe us. They are the guardians of our planet. They allow us to keep an eye on the effects of climate change, prevent the consequences, act in case of emergencies, and keep our infrastructure under control. The ESA has also signed a large part of the International Space Station itself, and also has its own spaceport in South America, the one in Kourou in French Guiana. In short, decades of great successes with a single worry: that of not having yet been able to land its own lander or rover on the surface of Mars. It has tried twice, and both attempts have resulted in failure. The first time happened with the mission that brought then into Mars orbit the probe Mars Express, but that also had to bring down on the sands of Isidis planitia the small lander Beagle 2 built by the British Space Agency. The lander separated from the probe on December 19, 2003, and after 6 days should have landed on Mars, braked by a series of parachutes and protected by some airbags at the time of impact with the ground. It was photographed by the mother probe on Christmas Day of 2003 while it was preparing to descend. Then nothing more was known. It was speculated that it had missed the planet completely, or that it had crashed. Then in 2015 it was discovered that it had managed to land, but that the solar panels had not opened properly, thus depriving it of the possibility of communication. The one that really crashed was the Schiaparelli lander during ESA's second attempt to land on Mars. This time the mission, carried out in collaboration with the Russian Space Agency, was ExoMars 2016, also composed of a probe, the Trace Gas Orbiter, which managed to regularly enter Martian orbit, and the lander dedicated to the memory of the Italian astronomer. However, the communication with the lander stopped about 50 seconds before the expected ground contact, just after the parachute and the heat shield had been released from the lander. Further analysis of telemetry data transmitted in real time by the lander allowed ESA engineers to discover that the retro rockets had been turned off by the onboard computer after only 3 seconds, instead of the expected 30 seconds. According to ESA estimates, the lander had traveled in freefall about 3 kilometers and impacted with the Martian soil at a speed of 300 kilometers per hour, spreading its wreckage among the sands of Meridiani Planum. In short, apart from the orbiters regularly entered in service from Mars, ESA has so far received only great disappointments, minimally mitigated by the objective difficulty that all space agencies of Earth have found in making a soft landing. But woe betide giving up. The ExoMars 2016 mission was in fact only the first phase of a more articulated mission, which later included the launch of ExoMars 2018, intended to bring to Mars the first European rover. But even with ExoMars 2018, considerable difficulties arose. Initially, the whole mission was supposed to be an ESA-NASA collaboration, but then, when by then the European agency had already started the plans for its realization, NASA withdrew from the agreement for budgetary reasons. So ESA turned to Roscosmos, which was desperately trying to get back on track after previous failures, in particular that of the Phobos Grunt mission, which was supposed to bring back to Earth samples of the Martian moon Phobos, but because of a malfunction of the last stage of the carrier, fell back into the Earth's atmosphere, burning completely. The change of partner was not painless. Less money, many technologies to be replaced, much time lost. The second mission, initially scheduled for 2018, has slipped by 2 years, thus becoming ExoMars 2020, and then by another 2 for problems encountered in the parachute tests, and for the slowdown due to the pandemic. So now we're talking about ExoMars 2022, a mission that, if all goes well, will be launched on a Proton-M rocket from Baikonur, Kazakhstan, in the 20 November 1 October 2022 launch window. It is planned to land on Mars in the Oxia Planum region on June 10, 2023. During launch and cruise phase, a carrier module provided by ESA will transport the surface platform and the rover within a single aeroshell. A descent module, provided by Roscosmos, will separate from the carrier shortly before reaching the Martian atmosphere. During the descent phase, a heat shield will protect the payload from the severe heat flux. Parachutes, thrusters, and damping systems will reduce the speed, allowing a controlled landing on the surface of Mars. Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell. You will help us to make products of ever higher quality.
If you'd like to help improve the quality of our content, please check us out on Patreon. We would like to say a big thank you to all those who show their support.
After landing, the rover, recently named in honor of scientist Rosalind Franklin, who made key contributions to the understanding of the molecular structures of DNA, will egress from the platform to start its scientific mission. The primary objective is to land the rover at a site with high potential for finding well-preserved organic material, particularly from the very early history of the planet. The rover will establish the physical and chemical properties of Martian samples, mainly from the subsurface. Underground samples are more likely to include biomarkers since the tenuous Martian atmosphere offers little protection from radiation and photochemistry at the surface. The drill is designed to extract samples from various depths down to a maximum of 2 meters. It includes an infrared spectrometer to characterize the mineralogy in the borehole. Once collected, a sample is delivered to the rover's analytical laboratory, which will perform mineralogical and chemistry determination investigations. Of special interest is the identification of organic substances. The rover is expected to travel several kilometers during its mission. The ExoMars rover provides key mission capabilities: surface mobility, subsurface drilling, and automatic sample collection, processing, and distribution to instruments. It hosts a suite of analytical instruments dedicated to exobiology and geochemistry research. This is the Pasteur payload. The rover uses solar panels to generate the required electrical power and is designed to survive the cold Martian nights with the help of novel batteries and heater units. Due to the infrequent communication opportunities, only 1 or 2 short sessions per day, Rosalind Franklin is highly autonomous. Scientists on Earth will designate target destinations on the basis of compressed stereo images acquired by the cameras mounted on the rover mast. Rosalind Franklin must then calculate navigation solutions and safely travel approximately 100 meters per day. To achieve this, it creates digital maps from navigation stereo cameras and computes a suitable trajectory. Close-up collision avoidance cameras are used to ensure safety. The locomotion is achieved through 6 wheels. Each wheel pair is suspended on an independently pivoted bogie, the articulated assembly holding the wheel drives, and each wheel can be independently steered and driven. All wheels can be individually pivoted to adjust Rosalind Franklin's height and angle with respect to the local surface and to create a sort of walking ability, particularly useful in soft, non-cohesive soils like dunes. In addition, inclinometers and gyroscopes are used to enhance the motion control robustness. Finally, sun sensors are utilized to determine the rover's absolute attitude on the Martian surface and the direction to Earth. The camera system's images, combined with ground-penetrating radar data collected while traveling, will allow scientists on ground to define suitable drilling locations. Rosalind Franklin's subsurface sampling device will then autonomously drill to the required depth while investigating the borehole wall mineralogy and collect a small sample. This sample will be delivered to the analytical laboratory in the heart of the vehicle. The laboratory hosts 4 different instruments and several support mechanisms. The sample will be crushed into a fine powder. By means of a dosing station, the powder will then be presented to other instruments for performing a detailed chemistry, physical, and spectral analysis. The chosen landing site, Oxia Planum, is a 200-kilometer-wide clay-bearing plain located inside the Oxia Palus quadrangle on the eastern border of Planitia. The plain lies between the Morth Vallis outflow channel to the northeast and the Ares Vallis outflow channel to the southwest. Oxia Planum contains one of the largest exposures of rocks on Mars that are around 3.9 billion years old and clay-rich, indicating that water once played a role here. The site sits in a wide catchment area of valley systems, with the exposed rocks exhibiting different compositions, indicating a variety of deposition and wetting environments. A period of volcanic activity may have covered early clays and other aqueous deposits, offering preservation for biosignatures against the planet's harsh radiation and oxidation environment, and have only been exposed by erosion within the last few 100 million years. Well, that's it. We are still 2 years away from the arrival of the rover on Mars. Let's cross our fingers and hope that Rosalind Franklin will be able to find on the red planet the most important thing in the universe: life, in whatever form it is.